Imagine holding a glass of seawater. It's salty, sticky, and definitely undrinkable. Now picture a glass of river water, fresh, clear, and in its natural form safe to drink. Both come from the same planet. They're part of the same water cycle, and yet they taste completely different. Why is that? Why is the ocean salty but rivers are not? To answer that, we need to understand something much bigger: the journey of water on Earth. Water is constantly moving. It evaporates from the ocean's surface, rises into the sky, forms clouds, falls as rain, and flows down mountains and valleys through rivers, back to the ocean. This endless loop is called the hydrological cycle. But hidden within this cycle is the reason oceans became salty. Rainwater may seem pure, but it's not. As it falls through the atmosphere, it absorbs carbon dioxide, turning into a weak form of carbonic acid. This slightly acidic rain reacts with the rocks and soil it lands on, gradually breaking them down in a process called chemical weathering. This process releases minerals from the rocks: sodium, calcium, magnesium, potassium, and others, many of which are carried away by rivers. Among those minerals is sodium chloride, or common table salt. Rivers pick up tiny amounts of it as they travel, and although river water does contain dissolved salts, the concentration is so low that it still tastes fresh. But when those minerals reach the ocean, something different happens. Unlike rivers, the ocean has no outlet. Water enters the ocean through rivers, but it leaves only through evaporation. And when water evaporates, it leaves the salt behind. Over millions of years, this has caused salts to build up in the ocean. The ocean, in essence, is a giant storage basin for everything rivers have carried into it over billions of years. On average, seawater contains about 35 grams of dissolved salts per liter. That's roughly 1 tablespoon of salt in every small bottle of seawater. In contrast, river water contains less than 0.5 grams per liter. The difference is staggering, and it's all because oceans collect, store, and never release those minerals. You might wonder, if this process has been going on for so long, why hasn't the ocean turned into a giant salt crystal? The answer lies at the ocean floor. Some of the minerals precipitate out and settle as sediments. Some are used by marine organisms to build shells and skeletons. And some of the salt is actually recycled back into the Earth's mantle through subduction zones, where oceanic crust is pushed under continental plates. Still, the process is slow. Every year, rivers bring about 4 billion tons of dissolved salts into the ocean. And every year, the ocean becomes just a tiny bit saltier. Not all bodies of water are equal either. Take the Dead Sea, for example. Unlike open oceans, the Dead Sea has no outlet at all. Water flows in, but it doesn't flow out. The only way water leaves is through evaporation, which leaves the salt behind. As a result, the Dead Sea is 10 times saltier than the ocean, with over 300 grams of salt per liter. Here's another twist. The ocean wasn't always this salty. Geological evidence suggests that hundreds of millions of years ago, seawater had a lower salt concentration than it does today. But with time and the unrelenting march of the hydrological cycle, the minerals added up. And so, today's ocean is a result of countless millennia of chemical erosion, slow sedimentation, and planetary recycling. So the next time you stand by the sea and feel the salt on your skin, remember this: every drop of that salt came from a rock somewhere, carved away by rain, carried by rivers, and captured forever by the ocean. That's why the sea is salty, and rivers are not. Subscribe us for more videos.